All right, so today we're starting Unit 2, which by far is probably my favorite unit of the whole year. And I'm going to tell you, there's going to be some silly emotions that you're going to come out of Unit 2. For some of you, you're going to be challenged for the first time ever. Like, math might also, you're like, this is not math. You'll actually probably get mad at me. Some of you are going to feel like you're in English class because we write so much incomplete sentences for this chapter. So this chapter is going to stretch you in a little different form than what you have, but it's a really good precursor for the rest of the year. Plus, it's kind of nice to know how you guys think and reason with stuff. So today we're talking about logical reasoning, and we're going to talk about the 3 types of reasoning, but we're going to really focus on one most of the time. Homework tonight, because I know I'll forget to tell you this later, is worksheet online. So there's going to be a worksheet online and also bookwork. All right, so you guys hear me? There's 2. Remember, you can upload a file twice, so you have it, both of them. If you want to do it on separate ones or together, I'm fine with that. But you're going to have a worksheet, and you're going to have bookwork on this one. But we're going to talk about the different types of reasoning. And the different types of reasoning sometimes is just how you approach something. But really, there are 3 basic ways. And I do expect you all to know the different types of reasoning and being able to identify them. The first type of reasoning we've already been doing right now in geometry. You do this a lot in your life. It's called deductive reasoning. Well, what is deductive reasoning? Deductive reasoning is reasoning based off of rules and facts. So off of rules and facts. For instance, if the tardy bell rings and you come in late, what are you? Because the rule is you have to be in the classroom by what? The tardy bell. That's a rule that you know. Facts. Guys, what's 1 plus 3? 4. Why? That's how you add, right? That's how you add. Well, let's even get fancier. That's how you add integers. You know, like that's how you add. You know that if you put 4 and then you add 1 more, you move 1 more over the number line and you get 5. Right? You learned the addition rule. Logical things that are also rule-driven. Like in 365 days from your birthday, you turn a 1 year older. That doesn't change. People my age might deny that, but it doesn't change, right? You get a year older. Any number multiplied by 1 is equal to itself. 5 times 1 is 5. That's a rule you learned. That's called the identity property of multiplication. Now, any mathematical rules, properties, postulates, theorems are all things you use in deductive reasoning. For instance, if I give you a midpoint, what do you guys give me? 2 congruent line segments, right? Because the definition, the fact is, that's what it does to a line segment, divides into 2 equal segments. See, that's just deductive reasoning. So do we use that a lot in math world and science world? Yeah, all the time. Then there's intuitive reasoning. Okay, now this one's a little bit more fun. It's reasoning based off of instincts. And this is where I'm pretty sure this is my definition, not anyone else's, and gut feelings. This is the stuff that you really can't explain, but you just kind of do. Like one of my favorite examples is, let's say many of you are going to get a driver's license within the next year or 2, right? Next year or 2. And let's say you're driving home from school. For some reason, you decide to take the long way home instead of the short way. You're like, I don't feel like going that way. I'm going to go this way today. And then you find out later there was a car accident on the other way home. Right? It was just one of those cool things. Or your moms do this to you and you know you hate it. You walk in the house, your mom's not even looking at you and she goes, "What's wrong, dear?" You know, you just get mad at them, right? You're like, how did she know? The moms just know. Sorry, moms just know. I'm one. I know. Okay, I just know.
What's Cora feeling?
What Cora's feeling today? Oh, she's in a good mood. What's up with that? All right, anyway. Think about it. When you were born, you did not think logically through your head, I'm hungry, therefore I'm going to cry. No, you just screamed bloody murder, okay? That's instincts. All right, let's go there. How about the stories of the twins that live on opposite sides of the country? One's in New York, one's in LA. Well, the one in LA got in a car accident, but for some reason, the one in New York felt their pain. You know, that type. Those are just instincts. I think it's really the Holy Spirit. But anyway, instincts, right? Or you've all done this. When you were little, you broke something. You didn't want your mom to know. When your mother came up to you and said, "Dearest, did you break that? What did you say?" You weren't being logical. You were trying to save your hide, right? You basically, anytime you lie, you're probably using this instinct more than anything else, right? You're using that type of reasoning. Now, athletes, don't you want to get to the point in your life where you have that type on the field or whatever you're playing, right? You want to get to the point where you just instinctively know, but does that take a lot of practice? A lot of repetition? Well, that's based off of inductive reasoning then. So just know that's our dream, our goal to get there. But this one, intuitive reasoning, is the most illogical thing out there. It's really the one that fills in the gaps. But the one we're going to really focus on today, besides that, is inductive reasoning. And you've used this quite a bit. This is what science is known for, okay? Inductive reasoning is reasoning based on observing patterns. This is where, guys, this is where they do those IQ tests. It's all based off of patterns. People think you're highly intelligent if you can see patterns. This is the number one reasoning you guys use every day. How many of you walk into this room and look around before you do anything? You're observing what's going on, right? You observe, is there something different? Did she move the desk? Darn, she moved the desk. There was a quiz I forgot about today, right? You know, that type of thing. You use the patterns to look at. How many of you the first day of school walked through the hallway and were watching what every other freshman was doing? Oh, yeah, you know you were, right? Some of you are like, oh, it's too cool for that, Gregerson. All right, they're watching me, right? But that was the pattern, right? That was the pattern. Think about this. Look at the second example, then we'll go back to the first one. Think what a person does when they walk onto campus. When you shadowed last year. Some of you shadowed. My kids don't shadow, sorry. They grew up here. But like, walk onto campus. You observe. Look what a visitor would do, okay? In the fall and in the spring, late spring and early fall, you can go and you can eat both places. So a visitor doesn't know the rules. They walk in, they see kids eating outside, they see kids eating inside. What are they going to conjecture? What are they going to think? Students going to eat what? Where are they? That's not wrong. They were just making an observation. Now, well, you can't eat in the atrium, but like that's the whole idea though, right? Like you can observe. Guys, you can learn a lot by observing. How many of you have ever been in a crowd before, like maybe at a new place, and you just sat back and watch until you figured out what was going on and then you went and did it? That's inductive reasoning. That's good reasoning skills. Think in science, that's observing patterns and then just making conjectures, right? A hypothesis about it. Well, we do it all the time with numbers. Think of number patterns. Here we got 7, 14, 21, 28. What's the next one? 35. 35. You just add 1, right? It's the next multiple of 7. Woo, great. Ones that are more like what you'd seen on IQ tests would be something like, oh, here's a triangle. I've got an arrow kind of drawn on the inside of it. Here's another triangle. One drawn here. Another one about it. And that's all I gave you. I said, make an observation, finish the pattern. What would you probably do next? Tell me, what would you do next? Yeah, I have the triangle, and I'd probably draw the arrow going up. And then if I asked you for another one, you probably would go to the right. Now, if I didn't really mean that pattern, you'd be wrong. But from based off of what I drew there, that makes logical sense to what he had. Because guys, can I make wrong observations? Can we observe patterns wrong? Yes. Yes. Our observation of a pattern can be wrong. We're not always right. In fact, a lot of times we skew it with ourselves, right? Like our own personal issues. We skew our patterns. But the thing is, you're working with it. Now, let me show you what an incomplete pattern can do to you, okay? Draw this for me out. Draw a circle with a line segment. Draw another circle with 2 line segments. Draw another one with 3 line segments. What is my next one in the pattern? Someone thinks 2 line segments or 1 line segment? That's what you think? That's a valid conjecture. That's a valid conjecture. Notice I'm going to be using this term a lot with you. Valid conjecture. What do you think, Michael? And then I'm going to go back to see. What do you think it is?
Probably a square since it keeps adding a segment.
So you think it's a square. What do you think, Evan?
I think there's a line going through the triangle.
Ooh, got a line going through the triangle? So you get 5.
Divided into 2 equal parts.
Oh, that's good. 2 equal parts. What do you think, Zach?
That it adds a 1, 2, 3, and then adds.
So you think 4. So I should have to get a 4th line segment at least. Well, here's the thing. Did I really give you enough of this pattern to let you have a good? No, I didn't give you enough. Because here's really what the pattern I wanted. I was going to put a quadrilateral in there. I didn't care if it was like a perfect one, but I would have put 4 segments in. And my next one would have been a lovely, very badly drawn pentagon. All right? But I was just adding a line segment and making it another polygon. But you really didn't have enough to go on. Really, if I was fair, shouldn't I have shown you the first 5 and then went dot, dot, dot? Yeah, to be fair. So you see how you can be wrong with a pattern, even though most of you were very logical and you had very good guesses, conjectures based off of it. Okay, you guys did really good. Yes, sir.
Can I go get a drink?
Yes. All right, so we're going to focus on this reasoning. Homework worksheets are literally, you're going to have to decide between if something's deductive, intuitive, or inductive. Okay? Now, here's the thing. People mess it up. You can have the same scenario with just a slight different twist, and it changes your reasoning. So be good. Use the R word, right, guys? Read carefully. If you're not certain, call Gregerson for help, right? Now, but today is all about inductive in the book. I love inductive reasoning. I love patterns. So we know it's based off of observing patterns, but notice I kept using this word, conjecture, okay? What is a conjecture? A conjecture is a statement you believe to be true based on inductive reasoning. So here's the thing. Notice it says you believe to be true. Doesn't mean it is true. No. So you can be wrong when you make a conjecture. That's okay. Scientists are great at being wrong. They make a hypothesis, they test it, they mess it up and go, that was wrong, let's try another one. Right? So a conjecture, you are going to be making conjectures. Think about it. You do it all the time. How many of you guys play sports and you go to a new place to play? Do you watch around to see what it's like? You get an observation, you're like, ooh, those stands are a little too close. Oh, this is a sweet field. I mean, you observe. That's the type of stuff you do with conjectures. All right, so complete this one for me. The sum of 2 positive numbers is positive. Now, how would I know if that's true? Well, why not add 2 positive numbers together, right? I could go 1,000 plus 1. Oh, that's 1,001. I could go 2 plus 3. Is that still going to be positive? Yeah. So we know we can make the pattern. We can make a conjecture based off of that. But again, to be true, though, notice this right here. That a conjecture is always true, you must prove it. Guys, proving it is a lot harder than disproving it. To disprove a conjecture, a statement of belief based off of inductive reasoning, you only have to show that one time it could be wrong. 99% of the time it could be right. That 1% of the time that is wrong makes it all wrong. Isn't that distinct? Like you can have this really good argument, but one time that someone throws a wrench into it, it's gone. So how do I prove that a conjecture is false? Well, you only have to ever find just one example. Okay, only one example that you have to show. But it's called a counterexample. Now, doesn't that sound like we're all of a sudden in court, right? You have your counter arguments. Those of you who want to be future lawyers, right? Mock trial. You give a counterexample. This is when you learn how to win arguments with your parents. If you find that one chink in your parents' argument that's wrong, it ticks us off. I'll tell you that right now. But when you're right and we can't argue back, you know you did a good job. I guess my goal is maybe to help you to argue with your parents better, but I don't know. But here's what a counterexample could be. It could be a drawing, a statement, a number. It could be an equation showing something is wrong. So really, it's just that one thing that makes it different, that makes it wrong. So here's an example of this. Show that the conjecture is false by finding a counterexample. So here's the conjecture that a person made. For every integer n, which means no decimals, no fractions, right? N cubed is positive. How many examples do I need? One. All right, Peter, what's one?
Negative.
All right. Yeah, if I use n is equal to negative 3, I can destroy this one, right? Because what do? I know that negative 3 cubed is going to be a negative, isn't that going to be 27? Negative 27, right? But the whole point was, I found an integer. I just had to show that it was a negative one could not make this work. And notice how did I substitute it in? I used what? Parentheses, so I didn't lose track of my negative sign with that. But yeah, it's going to be a negative 27. That is a counterexample. That's all you had to show. What do you guys think? Easy? Yeah, let's do another one. Determine if each conjecture is true. If false, give a counterexample. So if it's true, you just got to tell me it's what? True. If it's false, you got to show me why it is. Okay? So this first one, the quotient of two negative numbers is a positive number. What does quotient mean? Division, right, division. So basically, if I have one negative number divided by another negative number, is it positive? True. If you come up with a counterexample for that, you disproved something that's been going on for hundreds of years in math. So no, it's not going to happen. It's going to be a true statement. Every prime number is odd.
False because of 2. Yeah.
What number destroys it?
2.
False. 2 is an even number. So this time I wrote a statement down, but it makes sense. 2 is prime, but it's the only even one. But it's that one that disproves it, right? Hint, SAT, ACT, if they ever ask you for the sum of consecutive prime numbers, don't forget to start with which number?
2.
A lot of people will get it wrong because they start with 3 because they forget 2, because 2 is not odd. They assume it's not prime. So just a hint for your future life. You can, when you get your college scholarship, you can tell me thank you. All right. Guys, that's a groaner. Okay, I was too grown at that. All right, two sublunary angles are not congruent. I'm just saying any two angles whose measures add up to 180 cannot be congruent to each other. Yeah, it's false. Exactly. It's false because you can have, let's do it this way. You can have two 90-degree angles. And now, yes, I'm abbreviating with symbols. All right, because you can have two 90-degree angles. And they're what to each other? Congruent. Yes.
Future reference to the answers to this have to be complete sentences?
For right now, no. But make sure, because again, you can draw a drawing to do a counterexample, right? So with counterexamples, but if it's better to describe it in a sentence, yeah. Just remember, I need you to communicate clearly with me, right? All right, the square of an odd integer is odd. The square of an odd integer is odd. All right, what's the best thing to do if you're not certain? How about squaring? So I got 3 squared is what? Well, let's just say I want to make it miserable, and I'm like, oh, a negative 7 squared, so a negative. What does it give me? How about 3 squared? Well, actually, I did 3. Give me another one. 11. Let's go 11. That's a good number. 11 squared. True or false? True. Because, again, don't think... nice thing is don't have to worry about fractions and stuff because that's not an integer, but that is actually a true statement. Now, there's more than one way of solving for patterns. Sometimes you want to set up, literally like you see this problem down below, set up patterns that help you see things. So you look for those. So here's what I want you to do. All right, it says here, make a conjecture about the sum of the first 30 odd numbers. Now, some of you are quick to the technology. You're like, I'm just going to add up the first 30 odd numbers. Do you really want to take the time to add up the first 30 odd numbers? Especially if there's a shorter way, right? You'd get it right at least, right? But what if you typed in a number wrong? You just messed up the whole problem, right? There has to be an easier way. So, actually, we're going to use these columns to help us figure it out, okay? And we're only going to do the first 4 of these. The first 4. I'm going to define a variable. I'm going to let n equal the number of odd numbers added together. So in this one, that means n is going to equal 1. This means n is going to equal 2, because I'm going to use 2 odd numbers, right? N is going to equal 3, and n is going to equal 4. All right, so then I'm just like, okay, I'm going to show what I do here. 1 in itself is going to equal to be what? 1. 1 plus 3 is going to equal 4. 1 plus 3 plus 5 is equal to 9. 1 plus 3 plus 5 plus 7 is equal to 16. Now, is there any way that I can use my first column in order to equal that third column? Yeah. Great pattern that you guys saw. Can I square this one? Is that the same thing? So if I'm at the nth number, what would I do to that? Yeah, n squared. So guys, what is going to be the sum of the first 30 odd numbers? There should be an S there, by the way. It should be 30 squared, right? So 30 squared is 900. Actually,
the next one is obviously going to be 25 because 9 is not the next.
that is.
Oh, odd numbers without a lowest prime.
No, odd numbers, yeah. Prime numbers, no. Odd numbers, yes. Good way to look for holes in there. Good job. All right, let's try one more like this. It's so much fun. But you have to sometimes think outside of the box. All right. Make a conjecture about the sum of the first n even numbers and how one can quickly calculate them. All right, so can I start my setup the same way? Yeah, I'm going to still use the same type of idea to set this up. I'm going to go, all right, n equals 1, n equals 2, n equals 3, n equals 4, and I just want to be able to have some number of n times. What do I have? All right, so I look over there at my next two columns. I got 2 is equal to 2, 2 plus 4 is equal to 6. All right, so I'm thinking, like, how is it I can use 1, 2, 3, and 4 to get those answers, right? All right. What do you think? Brooke, what do you think you got?
You subtract the smallest number from the largest, and then multiply it by the amount of numbers.
Yeah, but that's hard. I don't think you're going to want to think of it quite like that. Think on that one. Josh.
For the first column, we have n equals 1. If you multiply by 2, you get 2. The next one, you multiply by 3, you get 6.
All right, hold on. What would you write down in this column? You said 1 times 2. What's the next one you do? You go what?
3.
2. No, 2. 2 times 3. What are you going to do next?
And 12, 3 times 4.
Great. And 4 times 5. Now, Brooke, see how close you were on this? All right. So with this one, what did I actually do? How did I get there? I looked for a pattern. I'm thinking, is there any way adding and subtracting wasn't going to help me on this one? Squaring didn't work this time, right? But notice, if I take 1 and I multiply it by 1 more than that, it works every single time. So your pattern would be what? N times n plus 1. Now, does that mean you have to think sometimes split things up a little bit? Notice how I wrote that last column. Yes, Jacob. Yes. So understand you could do it in this manner. So do you have to think a little bit differently? All right, guys. Now, remember your homework is both textbook and worksheet, but I want to have a little bit of fun. Are you guys ready to see if you're good at patterns? All right, I'm going to give you one right now. If you've seen this before, you cannot answer it right away. You have to be patient. Let other people struggle first. OTTFFSSEN. What is next? Remember when you were a kid, you'd instantly go look for a code with the alphabet, right? Not going to pay off. Anyone have a guess? Because remember, you can have a false conjecture, but could it maybe help someone else get it right? Any guess? What do you think?
It's going to be T.
I'm going to agree with you, but don't say what yet. The pattern is going to be T-E-T. Corbin, do you like to count? Why don't you count for me right now?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I've seen that before and I still think it feels so stupid.
Oh my goodness.
Why couldn't the letters represent a number? Which they do, but it's how you spell it, right? It's how you spell it. So obviously you'd go 8, this would be 9, 10, 11, and what? 12.
I've literally seen that before.
All right, here's one. I think this one's a little bit easier. I think this one's gonna be a little bit easier for you. Again, think outside the box. Kenny, what is it?
It's months, so January, February,
I need to write it down.
I know. It's like, I never gonna write it down. But think about it. Does time, is that a pattern? Don't we have patterns in time? So this is by month. So yeah, there's your January, your February, March, April, May, June, July. Goodbye, August. We're now in September, right? And it keeps going. So yeah, months could happen. Now here's one that's a little more fun. Are you guys ready? Days of the week? No, I'm not doing days of the week. Hardest thing when you're looking for patterns is being creative. All right, what do you see? Just start talking, guys. What do you see? Numbers, okay, numbers, okay. What do you see about them? Like, just start with the stuff that seems obvious to you. What do you see about the first three numbers? All right, so you said it looks like this, right? Why wouldn't I keep doing that?
Because maximum of 16. Use a words. Ow!
Okay.
Oh my God.
What's this one? Well, can I reverse 1? Can I reverse 4? Or 9? But, so that would be your hint. The first logic is, you guys actually, didn't you start seeing the squares?
Yeah. Yep.
Okay. But don't stop just because it's flipped around. Look and see if there's anything else with it. The moment I wrote 4 squared down, what did Josh do? Oh, like, it's flipped. I still was using my perfect squares, but sometimes when you look at patterns, it needs to be outside the box. Also, does it sometimes need to be done with someone else?
Yes.
Like, Josh wasn't going to be wrong, but when I started writing it down and he saw the visual, did he and I now become a team at solving them? So math, think about it. Math sometimes shouldn't be done alone, and sometimes it's okay to think outside the box, as long as you're mathematically well. Correct. All right, so that's the cool part about this. So make sure you guys